Objective 3.4. I can write the equation of a function in factored and standard form from using the key features on a graph. So we have our graph of a polynomial given here at the right, and a couple of things that we're looking for on our graph would be some key features. So we typically look for our x-intercepts first, and on our polynomial graph here, we can see that we have a cubic polynomial, so we've got three x-intercepts. One is at -2, 0, one is at 0, 0, the other is at 3, 0. We also want to look to see if there's any other points that we know the coordinates of besides the x-intercepts that we can use in help writing the equation. And we can see we've got two options given to us. We've got -1, 8. We also see 2, -16. I'm going to work with the -1, 8 as a point to help me write my equations. Now the x-intercepts are talking about the transformations kind of from your origin, and so if we have an x-intercept at -2, 0, we went to the left 2 units. Having an x-intercept at 0, 0 means we didn't go anywhere, and then having an x-intercept at 3, 0 means we went to the right 3 units. So we're going to start by writing it off in a transformational format. So I'm going to say f of x is equal to a times x plus 2, because that's my x-intercept of -2, 0, times x, that's my x-intercept of 0, 0, times x minus 3, representing my x-intercept of 3, 0. Again, we have the a value here because we're talking about transformations horizontally. We don't have anything vertically yet. That's what the a is holding the place for. So as I can see right now in this factored form, I have three variables, a, x, and f of x. When you're solving one equation, you only can have one variable. Therefore, I want to try to fill in for two variables because I really need to know what's happening vertically with a. That's where my point comes in. This point -1, 8 has an input value x of -1 and an output value f of x of 8. And so I'm going to substitute those into my factored form of the equation, -1 in place of x and 8 in for f of x. At this point, I'm just going to follow my order of operations and solve for a to see what's happening vertically with my function. So we're going to simplify what we have here. So we're going to have a 1, we still have a -1, we have a -4. Order of operations at this point would tell me to multiply my terms together. Well, a negative times a negative would be a positive. So right now I have 4. 4 times 1 is 4. So I have 4a equals 8. Again, we're trying to see vertically what's happening with a. Well, if it's 4 times a, to undo that, we could divide both sides by 4, which means that a would have a value of 2. It's increasing twice as fast. That's my vertical stretch. So if I'm going to write my equation in factored form, I would say f of x is equal to 2 times our quantity x plus 2 times x times our quantity x minus 3. Again, this represents the equation of our polynomial graph in factored form. All of that came from using the transformations from the x-intercepts and a point other than that that we know the coordinates on our graph. To put the equation into standard form, we would have to take the factored form here, perform the operations, combine your like terms.